Okay, so good afternoon. Thank you for coming to our session, AIM315. So as all of you here know today, the field of generative AI has exploded, is the best word, over the last 12 to 18 months. And it's been used by almost every organization in the world and be talked about on every single use case you can actually imagine. And that's not really an exaggeration given by our workload these days. But it's of a great interest to every developer, to every product owner, to everyone at the sort of VP level and at the CXO level. But there is one rather large elephant in the room when talking about generative AI, and that is security. More importantly, the security of your data and the privacy of that data. Because you've all seen stories in the press, of course, where data has been leaked from models, your training data, and been reused by other companies to train their models on your information without your permission. So what I could tell you, that with Amazon Bedrock, your usage of anything to do with Amazon Bedrock is not made available and completely private to every other model vendor. They just cannot see it. What have I also told you with Amazon Bedrock, with your inference data, it does not get ever used to train any other model ever, and neither do we even store it anywhere for later reuse or examination. It just doesn't exist. And what have you also said? In those very rare situations where we have to store your data, such as a fine-tuned, customized model, we will encrypt it with your own KMS keys. And so the only way you can access it is again, with your KMS keys. So my name is Andrew Kane. I'm the worldwide tech leader for all of our AI services. And for the last 9 months, I have fallen deep into the rabbit hole of Bedrock security.
And I am Laura Verhote, a solution architect in the public sector. And today we're going to discuss all of the different aspects around Amazon Bedrock security. So you can leave here feeling confident that Amazon Bedrock is a safe and secure service that can meet or exceed your GenAI security requirements. These are all of the different aspects that we're going to cover today. And hopefully you'll be able to answer any of the questions that you might have around Amazon Bedrock security. And so let's start with point number 1. What is Amazon Bedrock security? So that we can level set the room before moving on to the more security-focused aspects. So we just wanted to give you a high-level overview of what Amazon Bedrock is. This is not going to be your standard service introduction. We're not going to talk about all of the different features of Amazon Bedrock or about all of the specific models. This is just going to serve as a common starting point before we move on to the more security-focused aspects. Amazon Bedrock is a fully managed generative AI service that makes it easy for customers to build and scale generative AI applications. Customers are using Amazon Bedrock to easily take advantage of foundation models or FMs within their application without having to worry about the model deployment. So no infrastructure, no model training, no maintenance. And one of our commitments at AWS is providing customers with more choice when it comes to foundation models in Amazon Bedrock. And choice here is going to be a crucial point, because we don't believe that there's going to be one foundation model that is going to solve every use case, nor that there's going to be one flavor or one version of a foundation model that will do. Now, it's still early days. We're all just getting started, and customers are moving fast. And at the same time, generative AI is evolving quickly, with new options and innovations happening practically daily. And in times where there's so much unknown, the ability to adapt is going to be the most valuable tool. Customers need to be able to experiment, iterate, deploy, and pivot very quickly. And they want to be able to choose today's latest and greatest foundation model. And customers have told us that one of the most important features of Amazon Bedrock is how easy it makes it to experiment with, select, and combine a wide range of foundation models. And so this is why we've made building with a wide range of foundation models as easy as an API call. Today, Amazon Bedrock provides access to a wide range of foundation models from AI21 Labs, Anthropic, Cohere, Meta, Stability AI. We have our own Amazon Titan models, as well as the newly added Mistral AI models. And when it comes to building with generative AI, your data is going to be the differentiator. And so you can customize several Amazon Bedrock models by pointing Amazon Bedrock to your datasets in your Amazon S3 buckets. And there are two different ways that we can do this. First of all, we have fine-tuning. By providing a few hundred labeled examples of data, we can improve the model's performance on specific tasks. And so we're going to learn how to associate different types of outputs that should be generated by certain types of inputs. And secondly, we have continued pre-training. Here we're going to provide unlabeled data. And so we're going to allow the model to familiarize itself with certain types of inputs on certain domains it might not have as much domain knowledge on yet, and so increasing the model's accuracy on that domain. And so both of these methods make it possible to create an accurate, customized model without having to worry about collecting large volumes of annotated data like you would have to do if you train a model from scratch. And AWS is going to take responsibility here for hosting that model and making it available to only you. Now, one thing that is going to be absolutely critical for every organization using generative AI is that everything that they do is going to be private and that their data is going to be protected at all times. And questions that we typically get during early-stage customer engagements are, OK, who has access to my prompts and my responses? Will my data be used to train any of the models? And hopefully, by the end of this section, we will have answered all of these questions for you. So let's first have a look at data privacy and localization. And so this is going to be absolutely fundamental, and we may repeat it several times today. But we do not store your inference or customization training data. If we do not store it, it cannot leak, it cannot be seen by any model vendors, and it cannot be used by AWS for any other purposes. The only data that we do store is going to be the operational metrics. So, for example, usage data for billing purposes, or sufficient metadata to allow us to list customization jobs in the console. And of course, if you're going to fine-tune or customize a model, then we're going to have to save that model in order to host it for you. However, you can encrypt that model using your own KMS keys. Then, all of the data that is going to be used in an API request is going to remain within the AWS region of your choice. So let's say, for example, you send an API request to the Frankfurt region. Well, then all of your data is going to stay within the Frankfurt region. So it's not going to go to any other AWS region, nor traverse the internet. Then let's have a look at data security. A common adage when it comes to security is, if it moves, encrypt it. And so all of the communication to, from, and within the Amazon Bedrock service is going to be encrypted at rest and transit. So we're not going to have a non-TLS endpoint, and we require a minimum of TLS 1.2. However, we do recommend using TLS 1.3. If you need a FIPS endpoint, we have them in the US East 1 region and in the US West 2 region. Another common adage when it comes to security is, if it doesn't move, encrypt it. So all of your data is going to be encrypted at rest as well. And if you're going to fine-tune a model, by default, your data is going to be encrypted at rest using AWS managed keys. However, we do recommend that you encrypt your customization training data and your customized model using your own customer-managed KMS keys. And then lastly, Amazon Bedrock nicely integrates with our identity and access management service, which Andrew is going to go a little bit deeper into in a bit. And then let's have a look at governance and auditability supports. So AWS is going to export metrics to Amazon Cloud Watch and AWS Cloud Trail. And these are going to end up in your AWS account. So they're not going to be logged in the Amazon Bedrock service or sent anywhere else. And with our growing compliance suite, you can be sure that Amazon Bedrock is going to meet your regulatory compliance needs. We have some accreditations achieved already, and some others are in progress, and we should achieve those certifications in the coming months.
So IAM, Identity and Access Management, is the system within AWS that is there to grant users or principals the right and the ability to call certain actions to access certain resources and basically to operate the service. Now, as of last week, I think we had over 85 actions, and there's going to be more coming, as were more announcements last night. And so we think we've got everything covered. There's nothing particularly special about IAM in Bedrock, so I thought we'd just go through 2 or 3 of the more simplistic examples of the things you'll commonly find within your organization. First one is really how granular can you actually be within Bedrock with IAM. So you can allow and deny every action against every resource for every individual model. So you are free to be as coarse or as granular as you like with the access. It's absolutely fine to allow someone like myself to be able to fine-tune Titan text models, but not deploy them, because I'm not part of that budgetary process. Have someone else deploy them, but not call inference. Have someone else who can do everything, and a third team who can access that one specific financial services model that only they need access to. So you can be as open or as closed as you actually need to be for this. Fine-tuning is slightly more awkward, slightly more involved. So first thing you need obviously to do a fine-tuning job is to have access to all the actions, all the particular rights that you need to start a fine-tuning process. It sounds obvious. So the list on the screen is not quite exhaustive, but it's most of the ones you have to pay attention to. If you have all of these, you're allowed to start a fine-tuning job. Now on mine, I've just made the resource star because I'm allowed to do anything, but of course you might want to restrict that a bit more so you can only fine-tune Titan text, you can only fine-tune Cohere. It is completely down to you. But you don't actually do the fine-tuning. It's really an asynchronous job. Tell Bedrock to go and do it, and then your request is finished. It backs away. And so what we have to do is give Bedrock permissions to do things on your behalf. And we do this through the usual construct of a role. So you define a role for Amazon Bedrock to assume when it's actually doing the fine-tuning process, and it can go and essentially do everything on your behalf. So you've got to give it access rights to things like KMS keys to make sure it can decrypt your training data, and also to encrypt your new fine-tuned model, access to S3 buckets, access to your VPC constructs and things like that, which we'll talk about more shortly. But once you have that in place, you also have to give it access to your training data, because without that, it's all really a bit pointless. So you can point at buckets for training data, you can point at your buckets for validation data, and also other buckets for us to write job metrics out into for when the training has finished, because you do want to know what is going on. And with the release of a new model monitoring feature, these metrics are really useful to see, is this model performing well? Is it outperforming the baselines, outperforming other third-party models? And so those metrics are really, really important. The cross-account access to Amazon Bedrock is not something that comes up much if you're just dealing with the on-demand models, unless you have a reason to centralize all Bedrock access in one account, which some customers do. But if you do a fine-tuning model, they do take time to train. They do cost money to actually go through that process and have that job running. So not everyone wants to have the same model retrained in every account that you have across every region. So what we often do is have cross-account roles. Now, again, there's nothing special here. So this is just a really quick refresher on how this works, because many people don't really get to do it in their day job. But you'll find that in Bedrock, this is quite important for the use of fine-tuned models. So let's have 2 accounts. We have account role A and role B. Role A is in the ones account, and role B is in the twos account. Role A, they can do anything on Bedrock, because they've got permission in that account to basically call anything they like. But the poor people who have got role B in the twos can't do anything. So what do? Well, we're back down to basically having roles being assumed again. So we add a policy to the role B in the twos account to say, I am allowed to access role A in the ones account. Great. I now feel much more empowered to go there and do something constructive. But of course, nothing will actually work at this point, because role A doesn't trust you. So you have to do the inverse on role A, add another policy to basically say, we now trust people with role B in accounts 2 to assume me, and they can now actually all use those particular models.
OK, let's now have a look at the different model environments available to you. So we have 2 different types of model environments. And before we go into their differentiation, let's have a look at their common features. So no matter which type of model deployment environments that you're going to choose, the following apply. First of all, your data will not be utilized to train any models available in Amazon Bedrock. So I repeat, your data will not be used to train any models in Amazon Bedrock. So this means no input prompts nor response data. And so unlike other AWS AI services available today, where there's a default opt-in policy to use your data to train our models, Amazon Bedrock does not allow this to happen under any circumstances. There isn't even going to be a way to opt in here. Then all models available are going to be deployed and operated by the Amazon Bedrock service team inside AWS accounts that they own and operate. Now, what does this mean downstream? Well, no model vendors will have access to your customer data. So this means that no matter which model you're going to choose, from which vendor, independent if it's going to be on-demand compute or provisioned capacity compute, your data is going to be treated in the exact same secure manner. Then let's have a look at their differentiation. So first, starting with who can access my model. Well, first of all, with the on-demand, here this is going to be available to all AWS customers. So this means that we're all going to be sharing the same compute environment. Then on the other hand, we're into provisions. Here, this is going to be made available to just one single AWS customer. So we're going to have a dedicated environment of that model available to only you. Then let's have a look at what kind of model each one of them is going to run. For the on-demand, here, you can only run a baseline version of that model. So it's not possible to run a fine-tuned version of a model here. And it's also important to note that you cannot have your level of throughput altered. So the service team is going to scale this. You don't have a guaranteed capacity here. So this means that if there's a sudden spike in usage, it could be possible that your API request gets throttled until an automatic scaling mechanism kicks in. Then on the other hand, with the provisioned compute, here you can run both your fine-tuned version of a model or a copy of the baseline version of a model. And so here, the scaling team is not going to, or the service team is not going to scale this for you. So you are going to provision a model to a set level of capacity. And the benefit here is going to be that you have a guaranteed TPS availability.
OK, so we're going to do something we don't tend to do at these sessions. We're going to show you what happens behind the API calls themselves. We're going to show you some of the network flows, some of the data flows, some of the internal components, what's encrypted where, and just give you a view of what's actually there for the complete sake of transparency. So when we say we don't store your data in inference, it's true, you can see it. And when we say we store your fine-tuned models with your KMS keys, we will show you. So we'll start with some high-level flows first, and then get into the details of fine-tuning. So what you see on the screen right now is there is, on the right-hand corner, top right, there is a box which is called the Model Deployment Accounts. These are owned and operated by AWS, by the Bedrock service team. We have one of these per model vendor per region. Okay? And they're only accessible by us. None of the vendors can look at these accounts. They cannot access these accounts. They cannot get data into or out of these accounts. So they're all extremely safe and secure, and making sure everything in it is private to us. So when we actually deploy a model, we will actually store the baseline version of, say, Anthropic Claude 3, and it will be in the base model S3 bucket that you can see. So we'll deploy that onto a cluster that is the relevant size to handle so many tens of thousands of transactions per minute, whatever it happens to be. And we'll have multiple clusters of each one, just for sort of failover, redundancy, load balancing, all the usual things you have to do to provide a high throughput system. Your request will come in on the left-hand side, and I am permitting it will be passed to the runtime inference service as part of the service. What this will do, it will decode the request, decide, well, you're looking at this particular model from Cohere, so we need to go to the Cohere account. We have to find the right model for that particular one you want, and we'll send the request there. That'll be processed, response will be picked up, and passed back to the caller. There are all points in this process between every node that you can think of. The traffic is maintained at TLS 1.2 or TLS 1.3, depending which one you initiate. And nothing will be decrypted at any point in time and stored within those services, because everything's going to be transient going through the nodes. It's just there to inspect things. And nothing gets stored except for your CloudWatch metrics, your CloudTrail logs. They get sent back to your account. Now, when we get to the provision compute environments, it looks, thankfully, almost exactly the same. The only real difference is we store your customized models in a different bucket in that same account. So you'll have your 3 or 4 or 5, 10, however many you happen to have, customized models. And when you tell us to, we will provision one. You might have it for a day, a week, a month, just a few hours for a small test environment, but we will deploy it. Now, when the API calls come in on the left, it's exactly the same process. Everything's encrypted in flight at the whole time. I am permitting the runtime info service gets your request, it will decode it, find the model cluster in the right account, call it, get the response, and send it back. It's actually no different. So from a development point of view, it's really good, because the only difference you have between calling a baseline model and a custom model is literally one parameter in your API call. It's really that simple. So there's no difference in the output types or output formats. It's all exactly the same. Now, calling Bedrock, most of you will start off by doing things like in a VPC with an internet gateway. Some of you will start on-premise, just doing things off your laptops. And everything goes into the Bedrock regions, and it gets sent to the relevant account. Now, we have two shown here. We have the control plane account, and we have a data plane account. The data plane is for runtime services. So this is where inference requests will actually go to actually get your prompt and responses. And the control plane is for management services, so listing your customized models, creating a customized model, generally things like that. But internally, they're just split for clarity. And many AWS services actually do the same thing. So the internet gateway is actually there, but you notice that traffic will come out of it and go to the endpoint and stay within the big white box, which is the AWS region. If you make a request in Frankfurt, VPC to a Frankfurt endpoint, it will not leave Frankfurt. It's really that simple. There's no route we can think of that can actually go to the internet. So whether you use internet gateway or not, it doesn't really matter. The traffic stays within your environment. One thing that's kind of incorrect here is we mentioned AWS credentials on premises. Please don't. Use temporary credentials, obviously. So use things like I am roles anywhere or I am identity center to actually get temporary credentials you can use. Now, of course, if you don't need an internet gateway, don't have one. So what we do instead is we provision private link endpoints within your VPC to connect to those various control planes and data plane accounts. So you can get there through private connectivity, and you don't have to expose your VPC to incoming internet traffic, which you'd rather not do unless you can avoid it. Now, fine-tuning is slightly different. I'm going to go through a high-level slide quite fast, then we go into the actual details of how fine-tuning works. So conceptually, it's similar to inference. The request comes in, I am permitting, the thing that will get passed on to the training orchestration task. What that will do is it will create in the relevant account, so if you're training Titan text, it will go to the Titan account and create a model training job. This will be spun up, and it will then read your data in from your S3 bucket, which may or may not be encrypted. It's down to you. Hopefully, it's encrypted, and stream it back into the training job via your VPC. We will then train the model, create a customized version of that, encrypt it with your KMS keys if you give them to us, and we'll store it in the custom model bucket. You can then deploy it later when you really want to deploy it into production or into a test environment. Now, to go into a bit more detail, we're going to go through the flows and each step of the flows. Starting with the basics, you've got private link endpoints to the control plane and data plane from your VPC. Great. You've also got your S3 bucket with your training data, which you have encrypted with a great KMS key, and you're limiting access to that bucket to your VPC by using a gateway endpoint. And also at this point, you have nothing fine-tuned. It's all blank as far as provision models go. So we mentioned earlier that you actually have to give us permissions via a role to do fine-tuning. So this role really gets involved at all these different places. It has to be available to the service principal for Bedrock. It's going to contain information about the KMS keys it needs to use, access to buckets, etc. So all that information is there in that role. So when we actually make the inference request itself, along the blue line, the customization job will get spun up, and it will assume that role that you've given it. Now, one thing it will then do is it will go back to your VPC. It will create two elastic network interfaces, or two ENIs, or more ENIs, in a security group that you've made available to us. That security group is allowed to send traffic to the S3 endpoints, and it's allowed to send traffic to and from itself. And these ENIs are basically used by the training job to get to the S3 bucket. And so once those ENIs are in place, it will then read the data from the S3 bucket, decrypt it via the gateway endpoint, get it all back to the customization job, and it will slowly but surely train your model. One benefit of this approach is your S3 bucket is still locked down to your VPC. You've not had to say, let Bedrock access this, or give it any more rights to any other entity. It's just locked to wherever you were locked to before. And just by giving us rights to put an ENI in your VPC, we can stream the data that way instead. And it just means you don't have to open up that bucket, which keeps many security people, well, much happier. One thing that's worth noting, though, is when you give roles to our services generally, we use it for the duration of the API call, or for the job in this case. And we will create that customized model, we will encrypt it, we will store it, that's all great. We don't provision it yet. We'll provision it later. So what the training job also does, it grants permissions to Bedrock to use the encryption key later so we can deploy the model into an environment. And this is important because at some point in the future, you may see someone in security say, why is this grant being used here at random, strange times? It's because you're deploying the model for a few hours, turning it off, putting on at 9 in the morning, turning it off in the evening, off for the weekends. So it's being used at what seems like random times that are not associated with the training job. So it's worth warning that if you have systems that try and automatically remediate unexpected KMS usage, you must expect this one to happen, because it will. And we have had customers miss this point out when they built training jobs, and it's worth calling out that it needs to be done. Another thing in the bottom sort of left corner is there is communication between the ENIs that we put in your VPC. This is because if you have sort of 2 nodes or 4 nodes in the training job, we will have 2 or 4 ENIs in your VPC. So first, you have to pay attention to your IP address count, because we're going to consume IPs. And you also have to make sure, excuse me, that the security group can talk to itself. Otherwise, it will not be able to do it. Once it's complete, we're going to drop the encrypted model into the custom model bucket, encrypted with your KMS keys. If you don't give us your KMS keys, we're going to encrypt it anyway with a service-owned KMS key. There's just no way we're ever going to store any custom model from any customer unencrypted. So if you don't give us a key, it's encrypted. If you do with your keys, it's encrypted with your keys, which clearly from an audit perspective is much better. So once it's done, once it's provisioned, and we'll use that key grant at that point, the inference request will actually work exactly as you imagine. It goes to the relevant private link endpoint, which gets to the data plane account, which gets to the runtime inference service, which gets to the right model, gets response, and sends it all back. So this is really how the fine-tuning actually works. It's really straightforward. And once the actual training job is completed, you'll notice that the ENIs have gone. All the constructs in the VPC have gone. And at that point, there's no record or trace of your training job except for your customized model that's been encrypted. There's no training data, there's no logging, there's no evidence of it anywhere at all, except for that wonderful model that now exists.
OK, there are lots of different use cases when it comes to generative AI. And when it comes to text, we've seen that there are 2 main patterns. The first one, we pass some user or system-generated data to a GenAI model, and then it's going to act directly onto it. The second one here, we're going to hook up a system to allow our GenAI model to take user input and to then dive deep into external data stores to provide large amounts of live data as additional context. And so let's have a look at our first architectural pattern. As you can see, it's very simple. However, it's how a lot of our customers are using generative AI today. They're going to replace an existing piece of their application by a foundation model. So in this case, we have a call analytics system. And instead of using one separate AI model for summarization, another one for extraction of actions from the text transcripts, or another one for classification of topics, we're going to replace that by one foundation model here. And to quickly go over the architecture here to see how the data flows, we first have a call transcript that is going to be sent to some kind of compute. In this case, this is going to be our Lambda function. And inside of our Lambda function, we're then going to form our foundation model prompt. So we're going to tell what we want the model to do, how we want our response to be styled, and then we're going to send that to our foundation model. We're going to receive a response from that foundation model. And we're going to then pick up that response and merge it into our call analytics data structure. And we could potentially persist it into a backing store, such as DynamoDB. And the key benefits of this pattern are going to be the faster route to market and the faster time to impact. A second architectural pattern is going to be agents for Amazon Bedrock. So this is a fully managed RAG solution, and essentially we're going to answer user prompts with information from existing data repositories and from microservices, and it also allows us to take actions. So I'm going to send a prompt to my large language model, and my agent is then going to point my model at knowledge sources that are necessary for inference and perform data retrievals from API services. And so this could take several iterations to actually get the correct response, and these are all handled automatically. So you as a user are not going to notice that all of these different steps might happen in the background. And this architecture that you can see on the slide here could be used, for example, to answer questions around vacations. So here I'm going to ask a question on HR absence policies. And as you can see on the bottom right of the slide here, I have a HR policy document that is going to be saved in my data repository that is part of my knowledge base. And so my agent is going to retrieve that information in order to answer the question. Another example could be I can ask what is going to be my remaining absence balance here. And so in this case, the agent can call one of the API services in order to retrieve that information and then send that information back to my user. I could also ask it to execute actions, for example, booking my vacation. And what the agent is going to do then is it's going to execute all of the underlying steps that are going to be necessary to book a holiday. First of all, if I didn't give it enough information, it will prompt me for that additional information. For example, the start and end date of my vacation. Then it will have a look at my API services to get my vacation balance to see if I actually have enough days left for that holiday. And then it will book that request into my HR system. And to give you an idea, so this should give you an idea of how all of this works. Now, Andrew is going to walk you through a high-level overview of how the data flows are going to work.
So the RAG pattern, we think, is one of the biggest ones that's going to take over this year. RAG, either managed by yourselves or managed by us through agents for Amazon Bedrock. And so it's worth showing at the high level how knowledge bases and agents actually work behind the scenes. Now, we have got much more detailed flows on these as well, much like the fine-tuning ones, but there is no time to go through them today. So if you reach out to your account teams in the future, we have got them available to walk you through them. But at a high level, what knowledge base has is really two main functional aspects to it. There's the ingestion flow, where it'll get your knowledge base data and ingest it into some vector stores. And the other aspect of it is using it in runtime, asking it actual questions, trying to find out information about what's in there. So we'll start off really with the ingestion piece. So what's in play in account-wise here? There's a bottom right corner, which is the environments external to us and to yourselves. You can use embeddings databases or vector databases from Redis Enterprise Cloud and Pinecone. They're configured, managed, completely owned by you. So all we can say is use their best practice for encrypting and keeping them safe, because we have no ability to do anything with those directly ourselves. In the AWS accounts that you have, we have two other vector databases. We have Amazon Aurora and OpenSearch Serverless. They can both be public-facing databases, or they can be private-facing databases. Of course, you'll pick private, but Bedrock doesn't actually mind which one you use. So we'll use AWS Secrets Manager to actually handle sort of credentials for some of these systems. And you're going to hold all your data to be ingested in an S3 bucket. All of the ones in your accounts, you can use custom-managed KMS keys to encrypt. So please do. Which does mean when you use the APIs, of course, just like on fine-tuning, you have to give us permissions to actually access those relevant keys, which makes complete sense. So in the serverless account, we have two or three structures. One is a transient bucket, which is really used for checkpoints of the ingestion process. And that is going to be encrypted with your KMS keys again, customer-managed keys, because it's your data. There's going to be information in there that is not meant to be seen by others, so therefore it's going to be encrypted with your keys. Two other tables are Dynamo tables within the service team accounts. One is the metadata one, which is to do with holding the definitions of your knowledge-based sources, the current sync status of a current source as well, things like that, which are going to be encrypted by service keys because it doesn't require any PII information. It's just going to be managed by us. And the other table is the ingestion one, and that's really used for diffing, is the best expression, between the ingestion runs. So we know that between yesterday's run and today's run, we've got to add that row, take away that row, update that one, and things like that. So again, that's with server-side KMS keys. And all the values are hashed first before going in. So the process, as you can probably imagine, is you make a request to actually do the ingestion. We will read the data in for the data bucket on your side, decrypt it. We will break it into chunks, pass it to the LLM, the embeddings model, to get the embeddings for it, store the whole thing then into the relevant vector store you've told us to use. And essentially, that's all it does. When it comes to runtime, it's slightly different, and that we have another FM in place. So when you use knowledge bases, you can call it direct yourself, or you can call it indirectly using agents. It doesn't really matter how it gets there. The result is actually the same. But when you call it, you can just ask for the responses as they come out of the embedding databases, or you can use an LLM to actually rewrite that response so you get something else coming back. Entirely your choice. So once you have the response coming back, we will store that information in the session dynamo table, encrypted with your KMS keys, and return you a session ID. If in your next request to knowledge bases you use the same session ID, we will take into account the session contents in that table in the response. So you can have a longer ongoing conversation that could last minutes or hours. And once the session is closed, or after 24 hours, we'll just delete them anyway. So it does not last for very long, but it's just there so we can manage and maintain that conversation. Agents, we can't talk about the thing that was launched last night, which was the return to control aspect of agents, so we'll skip that now, but we just don't have the time to add in those extra slides. But they'll be available shortly from your account teams as well. So on your side, all we really have is a bucket, which will be encrypted with your KMS keys. If you've used agents, you know agents are used to trigger actions, or can be to trigger actions in your Lambda functions. And the Open API spec bucket defines your functions. It tells the agent, what does this function do? What's its purpose? What are its parameters? What does it return? Why does it work? Then it can form part of its orchestration process when it's doing chain of thought. Now, in the server side, we have a number of tables that we've just rolled together for the sake of this slide. And so they hold things like the agent definitions, the action groups that define the links to your Lambda functions, the aliases, things like that, things we need to be able to handle in the console and tell you what you've actually got. They, again, are encrypted with server-side keys, or KMS keys, at all times. So when everything is, when you run the agent or you define everything in the console or via APIs, that goes into the Dynamo tables. But we also have the information from the API buckets that comes in as well. And we'll actually essentially compile a really fast, compressed version of that we store in the agent def bucket. Because when you want to come in and run the agent request later, it's going to get put into live as an instance really fast. So we have this sort of intermediate compiled state that just makes our life easier when we get to the next slide. So at this point, you're doing the runtime flow. You've asked a single question. Now, what's appeared that wasn't here before is another session table. It works exactly the same as in knowledge bases. When you make a request to agents, you'll get a response. It will have a session ID. We will store the response with the session ID in that table, and we'll reuse that session information if you make a request with the same session ID. Again, after 24 hours, it's deleted anyway, and you can close the session at any time. Again, the purpose is to ask follow-up questions, so we don't have to go through the chain of thought process, which is quite time-consuming, to actually get the answer again, where we've half answered the question already. And so it really makes the agent interaction much, much faster and much more efficient. And for the last, we'll talk a little bit about responsible AI.
OK, now, no matter what generative AI service that you're going to choose or what foundation model you choose, one thing that is going to be fundamental that you should consider, and we can't have a session around GenAI security without mentioning it, is going to be responsible AI. So by considering what are going to be the implications on your customers and on your employees, you can save your organization from reputational harm and significant future rework while truly demonstrating customer centricity. And we see organizations doing this by having a responsible AI program. And what a responsible AI program is essentially going to do is it's going to look at all of these different aspects that you can see on this slide, and it's going to try to minimize or mitigate its impact. For example, if we have a look at hallucinations, we could minimize these impacts by using RAG against our own private data stores. Or if we think about bias, well, if you're going to fine-tune a model, it's going to be important that you are not going to introduce any bias into the model by fine-tuning it. Or if we have a look at the potential misuse and generation of harmful content and intellectual property, we actually have a feature in Amazon Bedrock called Guardrails that can help us with that. And I'm also happy to say that Guardrails is generally available since yesterday. And Guardrails allow you to implement safeguards that are going to be tailored to your application requirements. And it's aligned with your responsible AI program. It works with several foundation models and with agents for Amazon Bedrock. And what you could do, for example, is you could configure thresholds to filter harmful content to a varying degree. Or you could set up certain topics that you want your application to avoid by giving it a natural language description. For example, let's say you're a financial institution and you have an assistant on your website. Well, maybe you don't want that assistant to give investment advice. Well, then you can set that as a denied topic. And we also can detect and redact PII information in foundation model responses. And so how does it work? Well, it's going to intercept inputs and foundation model outputs, and it's going to check these, or it's going to evaluate these against different policies that are in your guardrail. And so your guardrail can have multiple policies of multiple types inside of it. And what's going to happen is, as you can see on this slide, we have a user input. This user input is then first going to be evaluated against all of the different policies that are inside of my guardrail. If it's going to trigger any of these policies, then I'm going to get a modified response back to my user that was set up by the creator of that guardrail. If my input is fine, then my input will be sent to my foundation model. And then my foundation model will create an output. And again, this output is going to be evaluated against your guardrail. In case it's going to trigger any of the different policies, you will get a modified response again. If your output is fine, then your output will be sent to the user. OK, so that was it. I hope we've answered all of the questions that you have around Amazon Bedrock security. If you have any more questions, Andrew and I will be available after the session. Also, if you want to learn about any other AWS-related topic, you can have a look at Skill Builder, where you can find over 600 free digital courses. So that was it. Thank you so much for being here. And if you enjoyed the session, please scan the QR codes to give us some feedback. Thank you.